First problem of the sheet is about a particle starting from rest and having an acceleration of 4 meter per second squared, and then reaching a maximum velocity, and then having a retardation of 2 meters per second squared, and eventually coming to rest, right? And the total time of the journey is given to be 12 seconds. We want to find the maximum velocity. So we draw the velocity time graph, linearly increasing, acceleration of 4 meter per second squared, and tan alpha will be 4. And then linearly decreasing, retardation would be tan beta, and that's going to be given by 2 like we've discussed before. And the total time of the journey is 12 seconds. I need to find Vmax, right? Hey, realize that this length is Vmax, right? Then this length is going to be, realize that this length by Vmax is cot alpha. So this length is going to be Vmax cot alpha. Yes or no? And again, this length by Vmax is cot beta. So this length is going to be Vmax cot beta. How about it? And if I add the two, I must get 12 seconds. Yes or no? So Vmax cot alpha plus cot beta is the total time 12 seconds. How about it? Nahin? Didn't understand? Didn't understand? What did you not understand? Huh? Nothing. You understood nothing here. Did you understand that this would be the variation of v versus time if acceleration is constant, and tan alpha will be 4? Did you understand that? And then velocity decreases, retards at the rate of 2 meters per second squared, and that tan beta would be 2. Did you understand this? And that the total time taken is 12 seconds. That's given in the problem, right? I want to find Vmax. Now this length is Vmax. Okay. Now this by Vmax is cot alpha. Did you understand that? So this must be Vmax cot alpha. This length by Vmax is cot beta. So this length must be Vmax cot beta. Did you understand that? So this length is Vmax cot alpha. This length is Vmax cot beta. And together they add up to 12 seconds. Are you sure about this now? So Vmax into cot alpha. What's cot alpha? 1 by 4. What is cot beta? 1 by 2 equal to 12. Or Vmax is, this is 3 by 4. So 12 into 4 by 3, which is 16 meters per second. That's Vmax. Yes or no? Okay, if tan alpha is 4, what is cot alpha? 1 by 4, isn't it? If tan beta is 2, what is cot beta? Half. Half plus 1/4 is 3/4. So into 4 by 3. Next situation is about a particle starting from rest and having a uniform acceleration, and after it reaches a maximum velocity and has a displacement s in that time. That means in t0 seconds its displacement is s. That means area of this triangle is s. That's what it means. Area of this triangle is s. Next, it moves with uniform velocity and undergoes a displacement 2s. That means area of this rectangle is 2s. And then it undergoes a uniform retardation and then executes a displacement of 5s till it comes to rest. That's what is given in the problem. Did you understand the problem? We want to be able to find the ratio of average velocity to maximum velocity. Clear? Now what I have assumed is that the first displacement s takes place in t0 seconds. That means area of this triangle is s. Area of this triangle is s. Now, would you mind believing area of this rectangle is 2s? That means this triangle is s and this triangle is s. Yes or no? That means if this triangle is s and this is also s, now they have the same height. They have the same height, so they must have the same base. Because this is s, this is also s, same height. They must have the same base to have the same area. That means this must be t0 units. Yes or no? This must be t0 units. Right? Now, look at this triangle and this triangle. Same height, but area is 5 times. This dotted triangle and this triangle same height, but 5 times the area. So base must be 5 times. That means this base must be 5 t naught, yes or no? Right? How about it? So what is the average velocity? Average velocity would be total displacement by total time. Total displacement is 3s plus 5s, 8s. By total time is 2 t naught plus 5 t naught, 7 t naught. That's the average velocity. Right? What about the maximum velocity? Hey, realize that S, this area is half of Vmax into T naught. This S is half of Vmax into T naught, right? So this S I replace by half of Vmax into T naught. Can I do this? This S can be replaced by half of Vmax into T naught divided by 7 T naught. T naught will get cancelled. So V average by Vmax is 4:7. 4:7. Yes or no? You got the same answer? Yes. Graphically? Very good. So it's again, like I said, in cases of constant acceleration, it's best to handle those problems graphically. See how easy it is, right? Algebraically, it'll get clumsy, right now? But did you understand everything that I've said here? The velocity as a function of displacement x is given as root 2x plus 9. I want to find what the acceleration of the particle is and what its initial velocity. See, again, there is nothing like an initial velocity. What they mean here is velocity when x is 0. Velocity when x is 0. That's what they mean by an initial velocity, right? So now this, if you realize, is v squared is 2 into 1 into x plus 9. Yes or no? Compare it with this equation. V squared is 2ax plus u squared. Right? Does it resemble v squared is u squared plus 2ax? It must be a case of constant acceleration out of comparison. V squared is u squared plus 2ax. It must be a case of constant acceleration. A must be 1. Yes or no? A must be 1 meter per second squared. And u, this must be u must be 3 meters per second. Yes or no? Isn't it? Got me? Shall we proceed? Very simple. A particle starts from rest, moves along a straight line with an initial velocity 0 and uniform acceleration a. I want to find the average velocity over a displacement s. I want to find the average velocity over a displacement s. Realize, after a displacement s, the velocity would be root 2as. Do you understand that? Yes. Average, it's a case of constant acceleration. So average velocity in this interval would be velocity at the beginning of the interval plus velocity at the end of the interval by 2. So v average in this interval is going to be u plus v by 2, which is root 2as by 2, which is root as by root 2. Very simple, isn't it? That's the average velocity. Of a particle as a function of time is given as mod of t minus 2. From 0 to 4 seconds, I want to find the distance traversed by the particle. Hey, one thing. Is the direction of motion changing during this? No, it is not. Because see, mod means V always remains positive. V never becomes negative. That means if V is maintaining the same sign, that means the direction of motion has not changed. You know what I'm saying? So if the direction of motion does not change, then distance and displacement will be the same. If the direction of motion has not changed, then distance and displacement, will it be the same? Yes or no? Nahi samajh mein aaya? Okay. Now, just to take you back to modulus, mod of x will be x when x is greater than or equal to 0, and will be minus x when x is less than 0. Yes or no? mod of x minus a. See, x could be greater than a or x could be less than a. When x is less than a, x minus a is negative. If x is less than a, then x minus a will be negative. And if x minus a is negative, then the mod of this will be minus of x minus a. That happens if x is less than a. Right? If x is greater than or equal to a, then x minus a is a positive number. Then the output of this will be the number itself. Yes or no? No? Got me now? So now, let me trim the velocity in terms of elementary entities. Velocity as a function of time is given by, now t could be less than 2, right? Up to t equal to 2, t less than or equal to 2. What's the velocity? T minus 2 will be negative, isn't it? When t is less than or equal to 2, t minus 2 will be negative, and mod of a negative number would be the negative of the number. So then it will be minus of t minus 2 when t is less than 2, because t minus 2 is negative, but minus of t minus 2 will be positive. So this is 2 minus t. Yes or no? For t greater than or equal to 2, t minus 2 is a positive number. So the output of a positive number is the number itself. Yes or no? So that's how velocity varies with time. Up to t minus 2, it's going as 2 minus t. 2 onwards, it's going as t minus 2. Right? Let me draw the velocity time graph. Let me draw the velocity time graph for this. But so far so good. Have you registered whatever I have said here? Velocity plotted in the y direction and time plotted in the x direction. So in the y direction, realize v versus t is a straight line, slope minus 1. Velocity is decreasing with time. At t equal to 2, it becomes 0. At t equal to 0, it is 2. At t equal to 0, it is 2. Yes or no? This is the velocity time graph, 2 minus t, y equal to mx plus c. M is negative, minus 1, negative slope. Right? And then, from 2 onwards, up to 4, y equal to mx, m is 1, plus c, c is minus 2. Right? It goes along this line. This is t equal to 4, y equal to mx plus c, y equal to mx plus c. This is how it goes? Yes or no? So then, in the interval 0 to 4, the total displacement is this area plus this area. That's the total displacement, and that's also the total distance, because the direction of motion has not changed. So this area is all that I need to find. Now this area is half of 4 units into, now realize that at t equal to 4, this length is 2. At t equal to 4, this will, v is becoming 2. At t equal to 4, v is becoming 2. So both these triangles, so double the area of these triangles. So half of 4 into 2, that makes it 4 units. Yes or no? This plus this area is 4 square units. Right? So the displacement is 4 units and the distance is also 4 units. Why is the displacement the same as distance in this case? Because the direction of motion has not changed. Why is the direction of motion not changed? Because the sign of the velocity has not changed. If the sign of velocity remains positive or remains negative throughout, then the direction of motion will not change. If v changes from positive to negative or negative to positive, then the direction of motion would have changed. But in this case, it is v is maintaining the same sign, so the particle is moving along the same direction. This would be this area would be the total distance, also the total displacement. Got me? Two particles P and Q are dropped from a balloon at a height h. The first balloon is moving with a velocity u, the second balloon is moving with a velocity 4u. So each of the particles will reach a maximum height and then fall back on the ground. I want to find out which of the two takes less time, which will reach the ground earlier. This is what I need to find. Now take a general case. If at a height h, if I launch a particle with a velocity u naught upwards, right? Let me take upward positive and downward negative, right? Let's say it takes t seconds to reach the ground. Let's say it takes t seconds to reach the ground, right? Now, I'll apply displacement is ut plus half at squared. When it reaches the ground, what's the displacement? Minus h, because I've taken downward negative, minus h. U will be u naught upward positive, u naught t. A is negative minus g because I've taken downward negative. Yes, so minus half gt squared. This will give me the time it takes if it's launched with a velocity u naught upwards, time for it to reach the ground, right? Now, this will give me like a half gt squared minus u naught t minus h is 0. I'll ignore the negative root because when it reaches the ground, that's a positive instant of time. So I'll ignore the negative root of this quadratic in t, right? So this gives me t equal to minus b. I'll ignore the minus sign plus u naught squared 4ac, so 2gh by 2a. This is what it is. So if u naught is more, time taken will be more. If u naught is more, time taken will be more. Isn't it? Do you realize that? If I increase u naught, t will be more, right? If u naught increases, time increases. It will take more time. Yes or no? So in this case, this has more velocity, it will take more time. So which will reach the ground earlier? P will reach the ground earlier. P will take less time. Yes or no? So there is a particle launched from the ground with a velocity u. At the highest point, obviously, velocity becomes 0, and capital H is the maximum height attained by the particle. All right. Now, there is an intermediate point P. Obviously, it will be crossed at 2 instants of time. At time t equal to t1 and at time t equal to t2. t1 is the time taken, is the instant when it's going up. t2 is the instant when it is coming down. And it's given that t1 by t2 is 1/3. It's given that t1 by t2, these are the 2 instants when it crosses P. Right? One would be t1 is when it's going up, t2 is the instant when it is falling down. Right? I want to find small h in terms of capital H. Now, would you want to believe that h is, if t is the instant when it crosses P, I'm taking upward positive, ut minus half gt squared, can I say this? Tell me. I've taken upward positive, so to reach P, say it takes t seconds. T is the instant when it's at P. T is the instant when it's at P. So can I say h is ut minus half gt squared? Can I say this? What will be the roots of this quadratic? T1 and T2. When you solve for T, the roots will be T1 and T2. Yes or no? Roots would be T1 and T2. Clear? Now this gives me half gt squared minus ut plus h is 0. Now, what would be sum of the roots? T1 plus T2 minus b by a. Yes, so 2u by g. What will be the product of the roots? T1, T2, 2h by g, c by a. Yes or no? Yes. Do you all understand this? T1 by T2 is 1/3. T1 by T2 is 1/3. So T2 is 3 times T1, isn't it? T2 is 3 times T1, right? Now plug in T2 as 3 times T1 here. T2 as 3 times T1. So you get 4 T1 is 2u by g. Yes or no? T2 is 3 times T1. You get 4 times T1 is 2u by g. Now look at this. Put T2 as 3 times T1. T2 as 3 times T1. So you get 3 T1 squared is 2h by g. Yes or no? From this equation and this from this equation. Yes or no? Now, let me eliminate T1 from these two. Let me eliminate. So T1, as you can see from this equation, is u by 2g. T1 is u by 2g, which I can plug into this. So 3 into u squared by 4g squared is 2h by g. Yes or no? right? This gives me, so this G gets cancelled. This gives me U squared by G is 8H by 3. U squared by G is 8H by 3. Hey, but do you realize maximum height we have learned is U squared by 2G? So U squared by G can be written as 2H. U squared by G can be written as 2H. So 2H is 8H by 3, or H would be 3/4 of capital H. Was this your answer? Yes, sir. H, same answer? Okay. I hope all of you have understood everything that I've said here. Right? This was 1 by V versus X given to you. And from x equal to 4 to x equal to 12, I want to find the time it took. I want to find the time it took to go from x equal to 4 to x equal to 12. I told you the area under the 1 by V versus X graph will give me the time. That means this area of this trapezium will give me the time. And this area is how much? Average of parallel sides. So half plus 2 by 2. That's the average of parallel sides into distance between them 8. That will be the time taken. Yes or no? Average of parallel sides, half plus 2 by 2 into the separation, 8 units. That's going to be the time it took. Right? Stand by. All of you got this right? Yes.